And you're going to notice that that happens every time you have an angle on the unit circle, right? Whatever that is without the coefficient on the top, that's exactly what your reference angle is going to be. Only when it's an angle on the unit circle. But if it's not, then you've got to do this. All right, but I'm going to still do that step anyways because it's still really important to know. You need to be able to find reference angles for any angle, whether it's on the unit circle or not. All right, second step, now I need to identify the value or values, right? We should probably add an S, right? Because we can have an X and a Y value like we do here, right? Cotangent, we know, is going to be the X value divided by the Y. So let's go ahead and find the X and that Y value of pi over 3, right? Because what I'm doing now is I'm taking cotangent of 4 pi over 3 and I am simplifying it to be the cotangent of pi over 3. The only thing we don't know is we don't know what the sign is, if it's positive or negative. But that's okay. We're going to figure that out by looking at what quadrant it's in. Okay, so I'm now looking for cotangent of pi over 3. So which of these angles is pi over 3? Well, this is the angle 0. This is pi over 6. This is pi over 4. And then this one is pi over 3. Now notice how the pi over 3 angles are always the closest to the y-axis, right? That's pi over 3. This one's 2 pi over 3. This one we saw was 4 pi over 3. And then this one is going to be 5 pi over 3. So hopefully you kind of seen that pattern. All right, let's get rid of some of those, and then we'll go ahead and look at our angles here. So we have our x and our y angles right here, right? So we're looking at this, here's my x, and there's my y. So now we're gonna say, okay, so this is gonna be equal to the x value, which is, let me double check, my x value is 1/2, divided by my y value, which is radical 3 over 2. The 2's are going to cancel. I'm going to end up with 1 over radical 3, which we already know is going to be equal to radical 3 over 3, right? I'm not going to show that work over again. Now, the third step is identify that quadrant and the sign, right? So we know that this is we know it's in the third quadrant. So now you got to ask yourself, okay, what's the sign of tangent in the third quadrant? Well, another strategy that we use here is we know that in the first quadrant, all trig values are positive in the first quadrant. In the second quadrant, we know sine is going to be positive. In the third quadrant, we know tangent is going to be positive, and in the fourth quadrant, we know cosine is the only one that's going to be positive. So we end up with this little acronym. It's ASTC. So the acronym that we use to memorize this is all students. We say all students take calculus, right? And this stands for all are positive. S is for sine is positive. T stands for tangent is positive, and then C stands for cosine, are all positive. So this one is in the third quadrant, right? So in the third quadrant, a tangent is positive, so that means cotangent is positive. So my final answer, cotangent of 4 pi over 3 is equal to positive radical 3 over 3. Okay? All right, let's keep looking at some more examples though. So we're looking at almost the exact same example that we did earlier, but now we're going to do it with reference angles. So notice we have the first quadrant already written out for us. So now all we got to do is find our reference angle, find the value, and then find the sine of it. So let's go ahead and find our reference angle. So negative 225 degrees. Now that angle is going to be in the third quadrant. So now I need to find what's the reference angle. What's this theta right here? Well, whoops, I'm sorry. negative 225. That's positive 225. So let's do negative 225. Sorry, negative 225 we know is going to be in the third quadrant, right? This is going to be negative 225. It's going to be here in the third. So I want to find the measurement from the x-axis to that angle right there. So the way I'm going to do this is we know this is 180. This is negative 225. I only want to find the difference. So the way we're going to find the difference is I'm just going to take negative 225 and I'm going to add it to 180. And that's going to give me negative 45 degrees. Okay. Now, I don't really care about the sign, right? So I'm going to take the absolute value of it because we know that reference angles are always going to be positive. Right, so 45 degrees here. So now we know that the cosine of negative 225 is really the same as the cosine of 45 degrees. All right, it's almost the same. The only difference is we don't know what the sign is. Is it positive or is it negative? But that's okay. We're going to find that out we'll find that out in the next. Well, actually, you know what? If you guys want, we can do it right now. All students take calculus. So in the second quadrant, only sine is positive. So in this case, our answer is going to be negative, right? Only sine is positive. That means cosine is negative. So whatever answer is, we know it's going to be negative. So step 3, let's go ahead and find that value. So what's the cosine of 45? Here's 45. Cosine is my x value. Done. Right, so the cosine of negative 225 is equal to negative radical 2 over 2. Right, and this is going to be my answer right here. All right, I wanted to look at 2 more examples of reference angles. But I wanted to go through these 2 a little bit quicker. That way you can kind of see why this is a good strategy to use. Okay, so cosine of 330 degrees. So the reference angle to that is just going to be the cosine of 30 degrees. Right? I would just do 360 minus 330 and I'd get 30. So now you go to your 30-degree angle here. This is my 30-degree angle. And the cosine is going to be the x value. So radical 3 over 2. So in this case, it's going to be equal to the radical 3 over 2. Now we got to figure out what quadrant it's in, right? Cosine of 330 is in the 4th quadrant. So all students take calculus. So cosine is positive. So that means this value is positive. Done. All right, let's go ahead and look at our other example. So sine of 11 pi over 6. So that is exactly equal to the sine of pi over 6, right? I'm just doing that trick where I just look at just the values, ignoring the top coefficient. Now, sine of pi over 6, well, find pi over 6. Oh, hey, it's same angle. But sine is the y value now. So now this is going to be equal to 1/2. And 11 pi over 6 is in the 4th quadrant as well. So in the 4th quadrant, only cosine is positive. So that means this is negative. So there you go, guys. Another couple quick examples. Okay, so now that we know how to identify or evaluate trig values, now we're going to go ahead and do the inverse. So, well, I see a little bit of a typo here, right? We don't want trigonometric trig, so just inverse trigonometric values. Okay. So recall the definition of an inverse, right? All I'm doing is swapping the x and the y value. So if we look at these examples down here, right, we're going to have the sine, the cosine, and the tangent inverse. So typically, we just like to restrict inverses to only sine, cosine, and tangent because those are the only, because those are on the calculator. There's no inverse cosecant, no inverse secant, or inverse cotangent on your calculator. So that's why we just focus on these three. So all we're going to do to understand what an inverse is we're just going to swap the values, right? The a is now going to go in the place of y, and then the y is now going to go in the place of a. So we're going to switch this, right? So now instead of the y, instead of it equaling to y, it's now going to equal to a. All right, and then instead of the a being inside of the sign, now the y value is going to be on the inside. And then same thing with the cosine, right? A is now what it equals to, and then x is now inside, right? The tangent A is now what it equals to, and on the inside, I'm going to have y over x. Okay, so would we get to graphing? These values are going to make a little bit more sense, but right now it's kind of not going to make sense. You're just going to have to trust me for it. But let's go ahead and look at some of the restrictions on this. So for sine inverse, the domain is going to be from -1 to 1, right? This is now the answer, right? Now whatever goes inside of the x are now your answers, right? The 1/2, the radical 3 over 2, the radical 2 over 2. All of those values are in between -1 and 1, right? Just like for cosine. And then the answers that we get are now going to be, the angles. Right? So we're going backwards. I'm giving you the answer, and now you're going to have to give me the angle. So if you notice for sine, I'm only looking at values in between -pi/2 and +pi/2. So for sine, the way I kind of look at it is if we start here at 0, if I go in this direction, I've got pi/2, and then if I go in this direction, I've got -pi/2, right? So any values from in between those two are going to be acceptable answers. If you get an answer that's out in like the third quadrant, then we're just going to rewrite that as something in the first quadrant, right? Or if we get something in, if you get something in the third quadrant, we would rewrite it in the fourth quadrant. And then if you get something in the second quadrant, we would rewrite that in the first quadrant. Okay, so let's see. Y is equal to the cosine inverse of theta. Same thing. The only difference with cosine is that the angles that you're going to give are going to be in between -pi and pi. So you're going to have, so your angles are only going to be from, there's a mistake there. This should be 0 to pi. Yep, it starts at 0, and then it goes to -pi and pi are the same thing. It goes from 0 all the way to pi. Okay, so let's go ahead and cross that out. This should be 0 all the way to pi. Okay, and then tangent. The domain here is -∞ to infinity. We haven't really seen values other than the values that are on the unit circle. So the biggest one I think we've seen is maybe like 2. Although if you get closer and closer to your 90-degree angles, you're going to start to get values that are bigger than 2. They're going to go on to infinity. And we'll see that when we start graphing. So the range, though, is going to be the important part for tangent, right? So just like sine, it goes from here all the way to here. All right, so let's go ahead and look at some examples and let's see what this is going to look like. All right.